Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. Student, I hope that you are well. I am also well. Today, I will discuss about differentiation exercise 9I. It's very important question for your examination. So let's go, student. Look at the board. In this exercise, maximum and minimum. So at first, we want to learn the increasing function and decreasing function. So student, what do we mean by increasing function? If as much as increases the value of x, then increases the value of any function y equals to f of x. That means the slope of a tangent is positive. The slope of tangent will be positive, which is drawn by the point on the function. So y equals to f of x is called increasing function. In the case of increasing function, the slope of tangent is positive. So dy dx greater than 0. So student, look at the board. Here x-axis and y-axis. Now here function f of x. This is y equals to f of x. Now here this angle is theta. Now this point is P. So decreasing function, in the case of increasing function, the slope of tangent is positive. So dy dx is greater than 0. Here dy dx equals to tan theta, because theta is positive direction to along x-axis. Here theta is less than 90 degree. So student, if dy dx is greater than 0, so dy dx equals to tan theta. Theta is less than 90 degree. So increasing function dy dx greater than 0, theta is positive direction. I hope that student you are clear. Again student, decreasing function. Now decreasing function. So here from diagram, that means this is y equals to f of x. Now it is x-axis and y-axis. So theta means it is theta. So decreasing function, in the case of decreasing function, dy dx is less than 0. Slope of tangent is negative. So dy dx is less than 0. Now here dy dx equals to tan theta, where theta is greater than 90 degree. Theta is greater than 90 degree. So this is decreasing function. This is theta is greater than 90 degree. So student, function y equals to f of x. In this figure, attention please student, in this figure, this is y equals to f of x. So here extreme point, and here maximum value, this is minimum value, and comparable, this is maximum and this is minimum. Similarly, maximum and minimum, maximum and minimum, maximum and minimum. This point is dy dx equals to 0. Means f of prime x equals to 0. This is extreme point. At the extreme point, dy dx equals to 0. So student, here maximum and minimum, maximum and minimum, maximum and minimum, maximum and minimum values. Now we have from figure one or many greatest and smallest value can be founded for a function. Condition number one or many greatest and smallest value can be founded for a function. And condition number 2, at any point the smallest of the function will be extreme, that greatest value of the function at another points. It's very important conditions. Attention please student, rules for finding the maximum and minimum values of function. Number 1 condition, consider the function as f of x. So let f of x given function. Number 2, one time differentiation, find f of x, find f prime x. This is equation number 1 and equation number 2. I say again student, first condition, consider the function f of x is equation number 1, find f prime x, equation number 2. And condition number 3, for maximum and minimum value, for maximum and minimum values, so f prime x equals to 0. Condition number 1, condition number 2, condition number 3, for maximum and minimum values, so f prime x equals to 0, then find the value of x. So let x equals to a and x equals to b. Suppose the value of x equals to a and value of x equals to b. Condition number 4, from equation 2, we have find f double prime x. From equation 2, again differentiation, then we get f double prime x. And condition number 5, if x equals to a, then f double prime a equals to, putting the value of x equals to a in double prime, so value is greater than 0, positive, so is greater than 0. Then we have function of f of x has a minimum value at x equals to a. So required minimum value at x equals to f of a. Again if x equals to b, then f double prime b, value of double prime b is negative, less than 0. Now we get f of x has a maximum value at x equals to b. So maximum value equals to f of b. So student, here condition number 6. I say again student, rules for finding the maximum and minimum values of function. Condition number 1, consider the function as f of x. Number 2, find f prime x. Number 3, for maximum and minimum values, So f prime x equals to 0. Then find the value of x. Let value of x equals to a and value of x equals to b. Again from equation 2 we get, then again differentiation, find f double prime x. If x equals to a, then f double prime a is positive, is greater than 0. So f of x has minimum value at x equals to a. So required minimum value, putting the value of x equals to a in equation 1. So we have f of a. And condition number 6, if x equals to b, then f double prime b is negative, so less than 0. So f of x has a maximum value at x equals to b. So required maximum value equals to f of b, putting the value of x equals to b. So required maximum value equals to f of b and minimum value of f of a. So student, memorize it, this 6 condition. It is very conditions for solve the math. I hope that student you are clear. Question number 12. Find the maximum value and minimum value of f of x, x cube minus 3x square minus 45x plus 13. So given, student, here given f of x equals to x cube minus 3x square minus 45x plus 13, equation number 1. Now first condition, here given f of x equals to x cube minus 3x square minus 45x plus 13. Then differentiating with respect to x. Differentiating with respect to x. Now we can write ddx of f of x, then ddx of x cube minus 3 ddx of x square, because 3 constant, so take it to the first position, and 45 constant, take it to the first position, ddx of x and ddx of 13. So student, we know that ddx of f of x equals to f prime x, and then using formula you have learned, student, ddx of x cube, take it to the power first position and power minus 1, then minus 3 ddx of x square, so take it to the power first position and power minus 1. Similarly 45 into ddx of x, ddx of x is 1 and ddx of constant is always 0. Now we have f prime x equals to 3x squared minus 6x minus 45, equation number 2. So student, here we have f prime x equals to 3x squared minus 6x minus 45. Now here condition 2. Next, condition number 3, for maximum and minimum values. For maximum and minimum value. For maximum and minimum values, so f prime x equals to 0. F prime for maximum and minimum value, so we know that f prime x equals to 0. Now putting the value of f prime x, here f prime x equals to 3x squared minus 6x minus 45 equals to 0. Then find the value of x. Now here dividing both sides by 3, so we have x squared minus twice x minus 15 equals to 0. X square minus twice x plus minus 15 equals to 0. Now middle term. So we can write x square minus 5x plus 3x minus 15 equals to 0. Now taking common x from first two terms, then we get x minus 5, and taking common 3 from last two terms, then we can write x minus 5 equals to 0. So student, now taking x minus 5, taking common x minus 5, and we get x plus 3 equals to 0. So x minus 5 equals to 0, or x plus 3 equals to 0. So value of x equals to 5, or value of x equals to minus 3. Value of x equals to 5, or value from equation 2 we get. From equation 2 we get here f prime x equals to 3x square minus 6x minus 45. Now again differentiating with respect to x, find f double prime x. Now differentiating with respect to x. So ddx of f prime x, and 3 take it to the first position. So ddx of x square minus 6 ddx of x, and minus ddx of 45. So student, we can write here f prime x equals to f double prime x. Now 3 into take it to the first position of 2 minus 1, and 6 ddx of x is 1, and ddx of constant is always 0. So f double prime x equals to 6x minus 6. So we have f double prime x equals to 6x minus 6. Now putting the value of x equals to 5, or x equals to minus 3. Now student, if x equals to 5, then f double prime 5 equals to 6 into 5. Here putting the value of x equals to 5, then we get 30 minus 6 is 24, is greater than 0. If x equals to 5, then value of f prime is 24, is greater than 0. 24 is positive, so function of f of x has a minimum value at x equals to 5. So function of f of x has a minimum value at x equals to 5. So minimum value equals to putting the value of x equals to 5 in equation 1. Putting the value of x equals to 5 in equation 1, then we get 5 cube minus 3 into 5 square minus 45 into 5 plus 13. So using calculator, student, here result will be minus 162. So result will be minus 162. I say again, student, if value of f double prime is greater than 0, means 24 is positive, so f of x has a minimum value at x equals to 5. Then required minimum value putting the value of x in equation 1, then we get required value, minimum value is minus 162. So student, again, if x equals to minus 5, so student, look at the board. Here again, value of x equals to minus 3. If x equals to minus 3, then f double prime equals to, f double prime is minus 3 equals to 6 into minus 3 minus 6. If x equals to minus 3, then putting the value of x is f double prime minus 3 equals to minus 18 minus 6 is minus 24 is less than 0. Minus 24 is negative values. So student, I say again, if x equals to minus 3, then we get f double prime minus 3 equals to negative. So function f of x has a maximum value at x equals to minus 3. So function f of x has a maximum value at x equals to minus 3. Now putting the value of x equals to minus 3 in equation 1. So required maximum value equals to, putting the value of x equals to minus 3 in equation 1. So minus 3 whole cube minus 3 into minus 3 whole square minus 45 into minus 3 plus 13. So student, minus 3 whole cube minus 3 into minus 3 whole square minus 45 into minus 3 plus 13. So using calculator, so result will be 94. So student, required minimum value is minus 162 and required maximum value is 94. I hope that student you are clear. Question number 16. So prove that the greatest value of x plus 1 by x is least than smallest value. So student, look at the board. Here given f of x, let student, question number 16. Now prove that the greatest value of x plus 1 by x is least than smallest value. Then let f of x equals to x plus 1 by x, equation number 1. Now student, differentiating with respect to x. First condition, let f of x equals to x plus 1 by x. Then second condition, differentiating with respect to x. So ddx of f of x, and here ddx of x plus ddx of x to the power minus 1, take it to the upward of x, then we can write x to the power minus 1. So student, we know that ddx of f of x is f prime x, and ddx of x, you have learned student, ddx of x is 1, and ddx of x to the power minus 1, then take it to the first position of power, then power minus 1. So f prime x equals to 1 minus x to the power minus 2, equation number 2. So student, we have f prime x equals to 1 minus x to the power minus 2. Now for maximum and minimum value. For maximum and minimum values, then we get f prime x equals to 0. For maximum, condition number 3, for maximum and minimum value, so f prime x equals to 0. Now putting the value of f prime x, here f prime x is 1 minus x to the power minus 2 equals to 0, then find the value of x. Then take it to the right side of x to the power minus 2, 1 equals to 1 by x square, or x square equals to 1, then we get x equals to plus minus root over 1. So value of x equals to, plus minus 1. So value of x equals to 1 and value of x equals to minus 1. Now student, here three conditions. First condition, let f of x, then second condition f prime x, third condition for maximum and minimum values f prime x equals to 0, then we get value of x equals to 1 and value of x equals to minus 1. Student, from equation 2 we get, equation 2 we have f prime x equals to 1 minus x to the power minus 2. Again differentiating with respect to x. So again differentiating with respect to x. Now ddx of f prime x and ddx of 1 and ddx of x to the power minus 2. So student, we have ddx of f prime x equals to f double prime x. We know that ddx of 1 constant is always 0 and ddx of x to the power minus 2. So take it to the first position of minus 2, x to the power minus 2 minus 1. So f double prime x equals to 2 into x to the power minus 3. Now f double prime x equals to 2 by x cube. Now if x equals to 1, then we get, so if x equals to 1, then f double prime 1 equals to 2 by 1 cube equals to 2 by 1 equals to 2. 2 is greater than 0. Again student, if x equals to 1, then f double prime 1 is get 2. 2 is positive number, is greater than 0. So f of x has a, function of x has a minimum value at x equals to 1. Now minimum value equals to, so required minimum value equals to, student. Now putting the value of x equals to 1 in equation 1, then we get 1 plus 1 by 1 plus 1 equals to 2. So minimum value equals to 2. So required minimum value equals to 2. Then student, again if x equals to minus 1, then f double prime minus 1 equals to, putting the value of x equals to minus 1. So we have 2 by minus 1 whole cube. So f double prime minus 1 equals to 2 by minus 1. So f double prime minus 1 equals to minus 2 is less than 0. Here minus 2 is negative, so minus 2 is less than 0. So function f of x has a maximum value at x equals to minus 1. So student, f of x has a maximum value at x equals to minus 1. So required maximum value equals to, putting the value x equals to minus 1 in equation 1, minus 1 plus 1 by minus 1, minus 1 equals to minus 2. So student, we have minimum value is 2 and maximum value is minus 2. Minimum value is 2 and maximum value is minus 2. So maximum value is less than minimum values. So we have maximum value is less than minimum value. Then we have maximum value is less than minimum value, hence proved. I hope that student you are clear. Student, question number 21 is very important question for your exam. Now 21 number, prove that the minimum value of 4e to the power x plus 9e to the power minus x is 12. Now student, let f of x equals to 4e to the power x plus 9e to the power minus x, equation number 1. Let f of x equals to 4e to the power x plus 9e to the power minus x. Now differentiating with respect to x. So ddx of f of x and 4 ddx of e to the power x plus 9 ddx of e to the power minus x. So student, first condition, let f of x, then differentiating with respect to x. So we have ddx of f of x means f prime x. 4, we know that ddx of e to the power x means e to the power x. Then plus 9 e to the power x means e to the power x, then minus 1. ddx of minus 1 minus x equals to minus 1. So f prime x equals to 4 e to the power x minus 9 e to the power minus x, equation number 2. Condition number 3, for maximum and minimum values, then we get f prime x equals to 0. Condition number 3, for maximum and minimum values, so f prime x equals to 0, then find the value of x. Now student, putting the value of f prime x, so 4 e to the power x minus 9 e to the power minus x equals to 0. Take it to the right side of 9 e to the power minus x, or 4 e to the power x into 9, 1 by e to the power x. By cross multiplication, 4 e to the power x equals to 9. Now we get here e to the power x whole square, then 9 by 4. Then student, here e to the power x whole square equals to e to the power x equals to root over 9 by 4, or e to the power x equals to root over 9 by 4, then we can write 3 by 2. Now taking both sides by ln e to the power x, ln 3 by 2. So take it to the first position of x, ln e equals to ln 3 by 2. We know that ln e equals to 1. So we get ln equals to 1, then the put value of x equals to ln 3 by 2. So student, here value of x equals to ln 3 by 2. So value of x equals to ln 3 by 2. Now from equation 2 we get, f prime x equals to 4 e to the power x minus 9 e to the power minus x. Now again differentiating with respect to x. Now differentiating with respect to x. So ddx of f prime x equals to 4 ddx of e to the power x minus 9 ddx of e to the power minus x. Now we have ddx of f prime x, f double prime x, e to the power x means e to the power x. Differentiating, we know that ddx of e to the power x equals to e to the power x minus 9 e to the power minus x. Again differentiation with respect to x minus x is minus 1. Now f double prime x equals to 4 e to the power x minus minus will be plus 9 by 9 into 1 by e to the power x. E to the power minus x, we can write 1 by e to the power x. Now if x equals to ln 3 by 2, then f double prime ln 3 by 2 equals to 4 e to the power ln 3 by 2 plus 9 e to the power ln 3 by 2. We can write, student, here e to the power ln x means x. So e to the power ln cancel, then we can write 3 by 2. Similarly, 9 into 1 by 3 by 2 e to the power ln x means only x. 2 and 4 cancel, then we get 3 into 2 means 6, 9 into 2 by 3. 3 and 9 cancel, then we have 3. So 6 plus 6 equals to 12 is greater than 0. So f double prime, value of f double prime ln 3 by 2 equals to 12. 12 is positive number, so greater than 0. So student, here x equals to ln 3 by, so f of x, since f double prime, value of f double prime is greater than 0, so function of f of x has a minimum value at x equals to ln 3 by 2. Then required minimum value, putting the value of x is in equation 1. If x equals to ln 3 by 2, so minimum value equals to 4 into, putting the value of x in equation 1, 4 e to the power ln 3 by 2 plus 9 e to the power minus ln 3 by 2. Then student, simplify. Now we have e to the power ln x means only x, and 9 into 1 by e to the power ln 3 by 2. Similarly, using formula, so 2 and 4 cancel, 2 into 3 is 6, and 9 into 1 by e to the power ln x means only x. So here 3 by 2, 6 plus 9 into 2 by 3, 3 and 9 cancel, 6 plus 6 equals to 12. So minimum value will be 12, hence proved. So I say again student here f of x, here f double prime ln 3 by 2 equals to positive number. So f of x has a minimum value at x equals to ln 3 by 2, and required minimum value, then putting the value of x in equation 1, then we get 12. So minimum value equals to 12. It is very important question for your examination. So student, see you again next class. Allah Hafiz.